So my name is Greg Verstraeten, and I'm a product manager for OKE. OKE is our managed Kubernetes service in OCI. And so today, I'd like to talk about Kubernetes, the best practices to run, to operate Kubernetes at scale. And so I'd like to organize this session and talk about Kubernetes, what makes it great, and where the complexity that we hear about is coming from. And then I'll talk about how to simplify Kubernetes at scale. And then I'm very excited about the next point, about serverless Kubernetes. So I'm looking forward to get to that point. And then I'll finish with a summary about where to run containers in OCI. So what makes Kubernetes great and at the same time complex? First, we all have the benefits of running containers. Before we had containers, we were running applications on virtual machines, and even before that, we were just running applications straight on bare metal servers. So we had to procure those servers and to run every new application, new servers. That was really slow to go to market with an application. And then virtual machines came along, and it simplified a lot of things. So we had a pool of servers on which we could run virtual machines, and one application per virtual machine still. The configuration of those virtual machines were not so easy. We had to use configuration management tools to configure the operating system and provision the applications. It was working well until the next upgrade. An upgrade would easily break the automation. So then came containers, and it was solving a lot of those problems. They were improving portability. So they are lightweight, and we build images for those containers. They can run anywhere, so we can go from in all clouds and run the same application that we built. They offer isolation, and so on a virtual machine, on a server, we can run multiple of those containers, and we can use the resources that we have more efficiently. To the contrary of virtual machines, it doesn't go with the full operating system. It's the containers are packaged with an application and the libraries to support the application. So we have a more efficient use of the server resources, and it offers a predictable runtime. So when I run my container image, I know that it's always going to be executed exactly the same way wherever I am in Azure, in AWS, or on-prem. All I need is a server with an operating system and the container runtime, and my containers is going to run exactly the same way. And it improved the build automation. The container image is a result of a CI/CD pipeline where I build my application along with the container image, and at the end, I've got an image that I can run in different places. And Kubernetes serves on the benefits of containers, but offers a way to run containers at scale. So Kubernetes provides you with the orchestration of many containers, of many applications over a pool of servers. with Kubernetes, you can scale your application from single containers to many containers. It adapts to the load, the workload that you have. It brings you resiliency, so you declare what state of you want to run your application, and Kubernetes makes sure that that the application would get there. If it needs one CPU, you get it, and when your application will need more, Kubernetes would take care of it. If something breaks along the way because you declared the end state, Kubernetes would reconciliate it. If a server fails, Kubernetes would make sure that the application gets rescheduled to where it needs to run. Kubernetes brings high availability in an application. You can define affinity and anti-affinity of the pods that execute your application. When you run in a cloud, you can say, all right, my application has to be in an availability zone or an availability domain, as we say in OCI, or it can spread across multiple of those availability domains. Kubernetes provide all the networking construct to run your applications in a very secure way. So you can define little virtual firewall rules within your Kubernetes cluster. So application are so only the communication that is allowed between application is done. DevOps, it improves your DevOps practice. Kubernetes becomes a target of a deployment, and because all the deployment is done through an API, it makes it easy to deploy your application that went through your CI/CD pipeline into Kubernetes. You're able to manage your microservices in a more efficient way, and so improve the time to market of your applications. And finally, Kubernetes has now become a standard, right? And it's open source. So you benefit from the open source, from it being open source. It's available in all clouds. It's available on-premise. And along with it, you have a rich catalog of applications that are made for Kubernetes, that are containerized and with a deployment available for Kubernetes. So you can build your application, run them efficiently on a standard platform that is Kubernetes, and benefit from dependencies and software to go along with it from a rich marketplace. But now, we talk a lot about complexity associated to Kubernetes. Year after year, the CNCF does the same survey. And complexity always comes on top of a reason why people don't adopt Kubernetes yet, or they don't adopt it to where to what they would like to do. So where is that complexity coming from? A lot has to do with the infrastructure, managing the infrastructure for the clusters, and the integration with peripheral software. What I mean by that is there's provisioning Kubernetes means provisioning the control plane of the clusters. It also means provisioning the data plane of the clusters. And the control plane has to be redundant. You have to apply security hardening. You have to make it highly available. And then developers, administrators logging into the cluster. So you need to integrate it with an identity management system. And then once you have done that, you have the data plane of your clusters where the application run. And so those applications, the more you put, the more resources you need in the data plane of that cluster. But more than that, the application requirements varies over time. And so what you might have put 3 servers at the beginning, quickly it's not enough. Or at one point in time, at 8 a.m., for example, a lot of people start to use your application, and 3 servers is just not enough. So it has to be to scale. A lot of the complexity and day-to-day operation is related to that aspect. And then Kubernetes evolves, and we have patches, we have upgrades. The operating system of the servers, they get security fixes that have to be applied. And because with Kubernetes, it's the best practice to have an immutable infrastructure, right? So it is important not to really patch the servers, but to cycle them. So we take the server, provision new one, and put it in a cluster and remove the old one. That is hard activity because it has an impact on the applications. And so we see many customers just struggling with upgrades. They put it off because they always have more things more urgent to do. And so upgrades means they have to put the teams together, plan 10 hours of work and synchronization, make sure that things are back working when the upgrades is over. Security, because you run many applications within the same cluster, how do you make sure that the developers that deploy their application, they follow the best practices? How do you make sure that the images that they deploy are free of bugs and security issues? And then when Kubernetes was designed, it was said at that time, well, let's design your application with 12 factors, meaning there's a lot of criteria, but storage has to be the state of application has to be in a database outside of the application tier. And so on the paper that was great, but Kubernetes quickly was used for any type of application, 12 factors or not. So a lot of applications that we want to run in Kubernetes have their state local, and Kubernetes honestly is not super great at managing storage. So when you run application with a state in your cluster, a local state, I don't mean the state that is outside in a database, you have to configure the provisioning of that storage. You have to manage the encryption of it, and of course the backup and restore of your data. And along with your application and the cluster, well, you need to manage to have the day 2 operation going on, right? So you need to observe the cluster, have the logging configured, and the monitoring of the cluster, the resources, and the applications. And so all of this makes it intimidating for people to start their Kubernetes journey. And as a result, on the CNCF survey, we see that complexity slow the adoption of it. So, as a cloud vendor, how can we simplify this Kubernetes experience? And here I'm going to talk about all cloud vendors. What all cloud vendors do to make the Kubernetes journey and use Kubernetes more efficiently and more simply. So in the cloud, you have the provisioning of clusters all taken care of. You specify the version of Kubernetes that you want to use. You configure the networking for it, and the clusters are installed. What's good in the cloud is that you have a variety of hardware options. So all the CPU architecture are there. You can pick Intel, you can pick AMD. You can even pick ARM processors to run your applications. And you have access to GPU. So if you want to run machine learning workloads, any workload that can offload some of the processing to GPU, in the cloud it's pretty easy to do. You just select the right shape for it. Cloud providers simplify the upgrades of the Kubernetes clusters, even though it's still you still have an impact on the workloads. You still have to. It's still on the principle that nodes are being cycled. So you still have some involved work there. And you have a managed cluster autoscaler. So you configure the autoscaler to increase the amount of resources when your application need it. You can customize your nodes according to your needs. You benefit from the way the cloud is organized. So in OCI, for example, we have availability domains, we have fault domains, and so your clusters take advantage of the way the cloud is built, and so that brings higher availability to your applications. And then the workloads benefits from the storage integration with what the cloud provider is bringing. So, for example, block storage or file storage, your application can use it to store the state. You have the ingress to your application that is taken care of because it integrates with the load balancer service that the cloud provider offers. In OCI, AWS, Google provide service operators. So from your Kubernetes cluster, you can provision other resources within the cloud, and that's done from the Kubernetes API. Observability is usually provided. Of course, you can choose to have your own Prometheus and Grafana dashboard to look at the resources. But in addition, you can rely on the cloud provider monitoring system and logging to troubleshoot your applications. And then you have a whole list of security features. Identity access management, integration, for example, networking that connects your application and your cluster to your network, and all kinds of other features. So OKE is the managed Kubernetes service in OCI, and so our goal is to simplify your experience with Kubernetes, making the operations easy, so you can consume Kubernetes with confidence and knowing that security will be a top principle. So OKE is built on an open standard. It's the Kubernetes the distribution that we use is open source, is CNCF compliant. So you have exactly the same code. It's not a forked project. It's exactly the same Kubernetes that CNCF publishes. In addition, you get a container registry that is container initiative compliant. And so with those open standard, you're not locked into OCI. You can bring your Kubernetes workloads, run them in OCI, and then decide to go to a different cloud or even on-prem. So OKE provision your clusters, provision the control plane and the data plane, and you benefit from the better price performance that OCI provides. You have access to all the compute shapes to run your clusters in OCI, and you know that it's at the best price. You benefit from the reliability of OCI. The way OCI is built brings you the peace of mind to execute your applications. All the regions are built into either multiple availability domains or fault domains. And so when you provision a cluster in those regions, you know that it's going to be spread across all those availability domains or fault domains. It's not a choice. We deploy the clusters to bring you the best availability and reliability. And on top of that, you benefit from a service level agreement that is on par with all the competitors. OCI is built with the key principle, with security as a key principle. And so the clusters that we deploy with OKE in OCI benefit from those security features. For example, when you deploy clusters, you have the API endpoint that is connected to your network. The API endpoint can be public or private depending on your needs. The data that you have in your clusters, like for example the secrets or the state of your applications, they're all encrypted by default. It's not an option. It's always encrypted. But you can choose to manage the encryption using your own key. In OCI, we have many regions, but and those are public clouds, and so of course OKE is available in all of those regions. So you can choose wherever you are in the world. There's always a region that is closer to you that satisfies your data residency requirements. But more than that, you also have the option to use OKE on Cloud@Customer, on those dedicated regions that would be used only by you in a data center that you choose. OKE is available either in the public cloud or a dedicated Cloud@Customer. And finally, you have the operators to be able to control from your Kubernetes environment all the resources that you deploy in OCI. So you can have a view of the cloud from the lens of Kubernetes. So Kubernetes by itself is not enough, right? You need the integration. We talked about the integration with identity cloud with an identity system as the first thing that has to be configured. Storage is another one. So on this slide here, you see your Kubernetes cluster in the middle, and all the interactions that it has with the cloud services in OCI. On the top, you can see the identity and access management. So that's something that you don't have to configure. That comes right away by using OKE. It integrates with identity and access management in OCI. And so that is important because you know that you have the mechanism to authenticate the users that are going to connect to your cluster. And you can federate, of course, identity and access management with your own identity system. Your users that are in your Active Directory, for example, are allowed to access the cluster, deploy resources. And of course, Kubernetes provides role-based access. So users can do certain action in your Kubernetes clusters, but not necessarily all. Your Kubernetes clusters use compute instances available as part of OCI compute service. So you can configure bare metal servers as part of your clusters or virtual machines with all the processor types that OCI provides. We rely on the great OCI networking to configure your clusters, and so you design your own virtual cloud network to connect your clusters, or you leave us configured the VCN for you as a template, and later on improve it if you need. To expose your application to the outside world or to your network, you need an ingress, and so OKE integrates with the load balancer that's in OCI, so you can get the traffic, distribute the traffic from your users to your applications running in your Kubernetes cluster. As I mentioned before, storage is not easy, and so OKE integrates directly with OCI block storage and file storage. We encrypt your data by default, and you can choose to encrypt this data using your own key. And provide all the mechanisms for the lifecycle of the storage. Your container images can be in third-party registries, or they can be in OCI container registry. And what's great with OCIR, with the container registry, is that you have the vulnerability scanning integrated. So all your images that you have in the container registry, you can scan them for vulnerabilities, and you can even block the deployment of those images in your cluster if they don't fit the standard that you decide on. And then you benefit from monitoring, logging, and audits in your clusters. Audits is by default. So anything that is anybody that logs in your cluster, change something, you can always look at it and look at what the users did. So you can have an efficient study of what's happening in your cluster. Make sure that all the actions are known and expected. So far, we had one way to configure the data plane of the clusters. And it's a traditional way with nodes. So you have multiple nodes in the data plane of your clusters, and those are called worker nodes in the Kubernetes vocabulary. And so those nodes are compute instances that OKE provisions, and that you can tweak the configuration to run as you need. And so we call that the managed nodes. You get all the features to cycle them when you need. You have an autoscaler to be able to grow and shrink the size of your data plane when application require more or less usage resources. And so the benefits. What's great with the managed nodes is that you have help to manage the lifecycle of them. OKE drives the lifecycle of those nodes, but you have control over the way they're configured. So, for example, you might need to run a specific antivirus compliance framework on those nodes. It's possible because you have access to the operating system, and you can run what you need, configure the operating system on those nodes the way you need. So it brings you a good balance of agility and control. And so lately we've been added advanced features to the management of those nodes. The first one is the add-on lifecycle management. So it came from requests from our customers, and they told us, hey, you provision a kubeproxy, which is a Kubernetes component. You provision the core DNS, and then you provide an upgrade, and so we apply the upgrades. But there's many times that we want to control when kubeproxy is updated, when core DNS is upgraded, and we want to control the version of it. We don't necessarily want to use the core DNS that you guys think that you guys provide. We want to have our own version. We want to be able to decide which network CNI we want to use in our cluster, and so those customers want more control over the version of software that runs in their Kubernetes cluster, and so now you will be able to control the version of the software and the lifecycle of this software using the add-on lifecycle management. When you configure your cluster or you edit your cluster, you can choose, all right, this kubeproxy core DNS, I want this version, and I'm the one controlling the versioning of it, the version of it. So when I upgrade my cluster, that stays the same, and I will decide when to upgrade those specific components. Up to last week, when you had some, so an application on Kubernetes is organized by pods, right? So a pod is one or multiple containers that are executed on a worker node that is a compute instance, either a VM or bare metal server. And so up to that point, there was two ways to authorize an application to access OCI resources. One way is to store user credentials as secrets in the cluster, and so your application or your containers would authenticate as a user to be able to access storage, object storage bucket, for example, or another secret in OCI Vault. That's not great. Another way to do it was to authorize the node as a principal, instance principal, to access those resources. And that was a great way because it's all controlled from OCI IAM, Identity and Access Management. You would say, all right, those nodes that are part of the clusters of this Kubernetes cluster, they're authorized to access the object storage or OCI Vault or whatever. The problem with the last approach is that all applications running on those nodes could access the resources. There was not a granular way to say, all right, I've got this application A access those secrets, but application B is not authorized. That was up to last week. Last week we released workload identity. With workload identity, solved that problem. You can say, all right, this service account that is used for this application running in that cluster can authorize my storage bucket X and secret X in Vault, and not the others. So you have a granular way to set to authorize your application to access resources. A lot of customers ask for that feature, and so we're very excited that it's now available and it's going to unlock a lot of use cases. You know, as part of the complexity, security was a big part, right? And so, how to ensure that the security best practices are applied? How to ensure that, as I'm a Kubernetes administrator for my cluster, I've got multiple people deploying things. It's hard to tell that every time all the deployment will have the security best practices that I want. And so container governance is an improvement that we're going to bring. It's not available yet, but it's something that we're going to bring to guide the administrator and a tenancy administrator and say, hey, see that what you did over there, that configuration, it's not great. We suggest that improvement. So you have an ongoing scan of everything of what you run in your cloud in the Kubernetes cluster to say this application it has a read-write file system, for example. We don't recommend it. Please, we recommend a read-only file system. Those pods don't have network security policies. We recommend applying them. So container governance is like a service that will run on the side of everything and look at the containers and give you advice on how to improve security. That will be coming soon. All right, I'd like to make a pause, short one. I'm very excited about this section here. We released it last week, and that's the result of more than a year of work of a team of very strong architects and developers. And we wanted to further simplify the Kubernetes experience in OCI. A lot of customers came and say, hey, you know, OK is great, but it's still a lot of work. It's still a lot of work to size the clusters. It's a lot of work to upgrade. What can you do? Can you do more to so we just have to worry about our applications and forget or like spend less time sizing the data planes, have the right resources for applications. What can you do? And so those customers want basically a serverless Kubernetes experience. They're comfortable with Kubernetes API, right? So the deployment of things is something that they own. They don't want to give it away, and they want to keep that same experience. What they don't want is to deal with the infrastructure. They don't want the node. Define a pool of nodes, of compute instances. They don't want to get into the business of growing it, of shrinking it, to optimize their costs. They don't want to be in a business of cycling those nodes when an upgrade is coming up and like push it back because it's so painful. So to address their requirement, we came up with the concept of serverless Kubernetes, and that is provided with virtual nodes. So with virtual nodes, you get a fully managed cluster. What we were talking about is a fully managed control plane for the cluster and like a semi-managed data plane. Here with virtual nodes, everything is managed for you. The operating system patching, of course, all the resources that are implementing your cluster, control plane and data plane, are all managed. The scaling resources when your application need them is also something that is being transparent to you. And the upgrades of the Kubernetes components, as well as the operating system, is also all managed. All you keep is the Kubernetes management. So the way you deploy your application through the Kubernetes API, the way you set security between pods. All of this is still your responsibility, but everything else that has more to do with the infrastructure is managed by Oracle. So you give all that away, but we made it in a way that you still get the control, all the control options. To run the applications the way as a transparent way for you. What I mean by that is some of our competitors have something similar, but you always have constraints. You have constraints on the size of your pods. You have constraints about how you would split your pods for your application across availability domains or fault domains. With virtual nodes, a virtual node is an abstraction of a regular node to Kubernetes. So Kubernetes sees this node as a node with close to unlimited capacity. And so it can schedule pods on them as a normal node. If a virtual node is in 180 and the other nodes are across availability domain, and you say, all right, I want to deploy my application and and spread across ADs. Kubernetes knows that it has to schedule the pods across those virtual nodes exactly the same way it would do with a normal worker node. Virtual nodes open the door to more security. For example, each pod is running in its own virtual machine, very lightweight virtual machine. And so what it means is that it opens doors to running using Kubernetes to run multi-tenant application, to run SaaS application with multiple tenancies within one Kubernetes cluster. So far, we were hesitant to do this. With virtual nodes, you have the isolation built in for each pods, and so that opens the door to it. Virtual nodes integrate with your VCN, so you control the network traffic to and from your applications. And finally, cost optimization is the last benefit of virtual nodes. With virtual nodes, you don't pay for worker nodes and the number of those CPU and memory for those nodes, but you pay for each one of the pods that you're running. So you have a pay-per-pod pricing model rather than a pay-per-node. So you don't have to worry about sizing nodes. You're not in a business of it anymore. You know that you pay for the pods that are running. You run no pods, you don't pay anything. So all the resources, control plane, cluster control plane, and the virtual and the pool of virtual nodes run in the OKE service tenancy. And so in your tenancy, you just have the VNICs that are connected, that represent the pods that are connected in your VCN. So there's no resources that, there are resources that represent your pods and the virtual nodes that run in your tenancy, but not actual compute resources. So as I said, you have the capacity management of your clusters that is taken care of. So you don't have to worry about it. You don't have to worry about node repairs and operating system patches. And the Kubernetes upgrades are something that we simplify. It's all fully managed. Let me get there. So with managed nodes, you deploy compute instances that are worker nodes. So you have to size them efficiently, right? You have to size them for all your applications that you're running, and possibly increase the size of the pool when application need more. With virtual nodes, you do not have to set any resources at the virtual node level. You pick an architecture, a processor architecture. AMD, for example, soon will support Intel and also ARM. So that's what you define at the virtual node level. It's a processor architecture. Resources are not defined there. Resources are specified when you do the deployment of your pods. So I've got an application. It's using 3 pods, and I know that each one of the pods needs 1 core and 2 gig of memory. That's what's going to be written in the manifest of the deployment of the application. And so the virtual nodes, OKE with the virtual nodes, will take that manifest, those pod spec, and say, all right, it has to go on resources on virtual nodes with that many CPU and memory. It needs to grow, no problem. We scale the number of pods for this application, and virtual nodes always have the capacity to take more. Now, upgrades is made seamless. Today, the upgrade of the control plane is easy, right? You just do an API call or click on the console, and the cluster, the control plane of the cluster is upgraded without any impact on the workloads. Virtual nodes, it's exactly the same way. And we're going to make it go along with the cluster. So when you upgrade the cluster, all the components, control plane, virtual nodes, and pods are getting upgraded all together. So virtual nodes are upgraded in place with no impact on the workloads. So you've got the control plane, virtual nodes, they're upgraded, no impact on the workloads. But then there's a tiny component that runs with each one of the pods, and that component is doing the network, takes care of the networking, and that's kube proxy. So each pod runs this tiny component, kube proxy, and depending on the version, we need to upgrade it. And so we take care of this upgrade. Each pods are going to be restarted onto the same virtual nodes. So you don't move workloads around, right? Each pod is restarted onto the same virtual node. So there you have a little impact on your application. But because applications are made of multiple pods, and because you can specify a pod disruption budget, you will be able to eliminate any downtime for your application. A pod disruption budget is a Kubernetes concept or object that says, all right, for this application, at any point in time, I need two pods running, implementing it. I load balance across those two pods, or it can be 10. And so what we'll do is we'll make sure that we don't go under the number of pods that have to be there at any point in time. So the use cases for virtual nodes are pretty much everything that you would want to run on Kubernetes. But the applications that are spiky in nature, that requires a lot of resources and then not much at all, will be at home on virtual nodes. Because you don't have to worry about the resources at the node pool level, at the node level. Whenever a job would be started, or whenever batch job or an application that requires more workload, more resources suddenly, we will provision it on virtual node transparently. A lot of customers listen to us pitching this new capability in OKE, and they're very excited about it. 8x8 is one of those customers. They see this feature as a way to reduce the operations linked to their Kubernetes cluster, and they're already testing it, and they're very excited about using it from now on. So finally, where do you run your workloads in OCI? On OCI compute, you can run anything, right? Anything there. You have access to the operating system. You manage everything from the operating system to your applications. If you want to run containers, of course you can run it on OCI compute, but is it really worth it? We don't think so. To run containers, you might as well run the Kubernetes from a Kubernetes way, so in a Kubernetes cluster. And so you have for this you have OKE with managed nodes or virtual nodes. If you want more control over the configuration of your nodes, you should choose managed nodes. If you want only the Kubernetes experience and just focus on your applications, choose virtual nodes. If you don't want Kubernetes, and we have customers who don't want Kubernetes, the teams don't have the Kubernetes skills, they're not ready to move to it. They can choose container instances. Container instances is a relatively new resource in OCI. It allows you to run your container images simply and securely in OCI. And finally, if you want to run your code and so for an automation in OCI, to implement an API, you can go with the OCI function. And so that's a whole panel, a spectrum. On one side, you have more control, but more operations. And the more you go towards virtual nodes, container instances, you get more agility and less operations. I'm done with this session. I think I went a little bit over time. Thank you very much.